Hey everyone, welcome back. Today we're going to dive into the hidden world of clean water, and we're going to focus on the relationship between two really important ideas, SRT and VSR. Now I know that sounds super technical, right? But trust me, once you get it, you'll see exactly how we turn some pretty problematic waste into an incredibly valuable resource.
All right, so here's the game plan for today. First up, we'll tackle the main challenge, what we're calling sludge. Then we'll break down our two key players, SRT and VSR. After that, we'll connect the dots and see how they work together. And finally, we'll look at why this whole process is just so important in the real world.
Okay, so once water goes through the first few stages of treatment, we're left with this one big final challenge, sludge. Let's dig into what that actually is.
I mean, it's a question we don't really think about, do we? You flush the toilet, the water disappears, and that's it. Problem solved, right? Well, not exactly. It's actually just the start of a really fascinating journey.
You see, that journey takes it to this hidden world of what's called sludge stabilization. This is where an entire army of microorganisms gets to work, just munching away and breaking down all the organic stuff in a really controlled way. And let me tell you, getting this part right is absolutely critical for keeping us and our environment safe.
So, to really get how this all works, we first have to talk about time. Specifically, something called solids retention time, or SRT for short. You can pretty much think of it as the master clock that runs the whole show.
So, technically speaking, SRT, which you might also hear called sludge age, is just the average amount of time that a solid particle, and especially our little microbe workers, gets to hang out inside the treatment system. It's all about how long they get to stay and do their job.
Okay, but here's an easier way to think about it. Picture a microbe hotel. All the microorganisms are the guests, and their job is to clean the place up. Well, the SRT is basically the hotel's rule about the minimum length of stay. If the microbes check out too early, the job just doesn't get finished. Simple as that.
And here's why that's so crucial. Some of the most important microbes for this job are really, really slow growers. So if the SRT is too short, we literally flush these critical workers right out of the system before they even have a chance to reproduce. That can make the whole cleanup process unstable, or worse, cause it to fail completely.
So, if SRT is how much time our microbes get to work, how in the world do we know if they're doing a good job? Well, that brings us to our next big idea, Volatile Solids Reduction, or VSR. This is basically their report card. VSR is a direct measurement of how well the cleanup went. Volatile solids is just the fancy technical term for the organic stuff in the sludge, the food that the microbes eat. So VSR tells us as a percentage exactly how much of that material they successfully destroyed.
Let's go back to our analogies, because they're pretty helpful. If the SRT is the microbe hotel's minimum stay, then the VSR is like the final inspection after they're done. It's the score that tells us what percentage of the mess actually got cleaned up. A high VSR score means a job well done.
And you know what? This score isn't just a friendly suggestion. In a lot of places, there are strict rules that say you have to hit at least a 38% VSR. That number is the benchmark that proves enough of the bad stuff has been removed to reduce pathogens and odors, making the final product safe and stable.
Okay, so we've got our time, which is SRT, and we've got our performance score, VSR. Now this is where it all comes together. Let's connect them, because this relationship is the absolute key to making this whole thing work.
And the core idea is actually beautiful in its simplicity. The longer you let the microbes stay at the hotel, meaning the higher the SRT, the more cleanup work they can get done. And that means you get a higher VSR. It's a direct link. More time equals a better cleanup score.
And we can see this clear as day in the data. Just look at this. If we increase the solids retention time from just 6 days up to 20 days, we see the cleanup score, the VSR, jump from 53% all the way to 66%. That is a massive improvement, and it all comes from just giving the microbes more time to do their thing.
Now, of course, while time is the main ingredient here, it's not the only thing. Other factors definitely play a part. Things like temperature, because warmer conditions can speed up the microbes, and good mixing, which makes sure they can find their food, are also super important for getting that final VSR score as high as possible.
So we've gone through the science, but now let's zoom out. Why do we actually care about this relationship between a microbe's work schedule and its cleanup score? Well, because it has some huge implications for the real world. Here's the big takeaway from all this. The operators at wastewater plants are, in a way, timekeepers.
They very carefully control the microbe clock, that's the SRT, to make absolutely sure they hit that critical cleanup score, the VSR. It's a very deliberate and precise balancing act.
And hitting that VSR target, that is how we do something that is, frankly, incredible. We take this sludge, which starts as a hazardous waste product, and through this elegant biological process, we transform it into something called biosolids, a safe, nutrient-rich resource that can be used to improve soil for farming or to help reclaim land.
It's really a perfect example of engineering with nature, happening all the time, right under our feet. Which kind of leaves you with one last question, right? What other invisible, complex systems like this are out there, working 24/7, quietly keeping our world safe and making it just a little more sustainable? Something to think about. Thanks for tuning in.